Okay, the wheel, we're going to build with a revolve, and there's some very specific things that have to happen with the wheel. So again, this is important, and there's also some new inventor tools that we're going to learn and apply with this as well. So we're going to start out by revolving the basic profile of the wheel, this cross section that we're looking at here. So the total radius, because of this round on the end, is 1 inch plus that 1/8 of an inch, so that would be 1.125. So let's go ahead, come back to the wheel. I'm going to build this in an orientation that's going to make it look like a wheel when we're done. So I'm starting on the flat plane, the XZ plane. Let's draw a rectangle and use that origin point when you're doing your rectangle. And then let's go ahead and add some dimensions, and we want to dimension everything with that origin point. So that's why I didn't create the dimensions with the tab dimension on the fly. And then the distance from that point all the way down to here is also that's the 1.125. Okay, next I want to draw another rectangle, and we can just eyeball it for now. Again, I want to dimension from the origin point. So the distance from that line to that line is 1/4 inch. And the distance from that line down to this line is 3/4 of an inch. And the distance from that line across to that line is 1/8 of an inch. Okay, so everything we measured from that corner. Then let's trim that side. Okay, and you'll notice we lost some of our dimensions. So let's go ahead and make sure that's 1/4 inch, and now it's fully constrained. Okay, the next thing would be to add the fillets to round it off. So the 4 of those fillets are 1/16 of an inch. And then the fillets on the end that make the wheel round are 1/8 of an inch. Okay, so now we could finish the sketch. Go ahead and revolve. Of course, we want to do a full revolve. It automatically selects the profile, and then you have to select the axis of revolution. Okay, so there's the basic shape of the wheel. If I throw a sketch on there to start out, then we could go ahead and drill the hole, which is 0.28 inches. Now that's going to make that a clearance hole so that it will not be a super tight fit on the axle, which is 1/4 inch diameter. So next thing we want to do is we want to get this peg built. So to build the peg, it's 0.7 from the center. We'll go ahead and put a sketch on that flat face, and one of the tools we're going to want to use here, we need to totally see inside. So let's see, where is Slice Graphics? Oh, it's a right-click feature. Okay, it's on your computer. You can probably use F7 On my laptop, F7 controls sound, so I can't use that fast key. But if you right click and do slice graphics, notice that cuts away the part of the wheel, because the problem is the center point for that wheel, I want to make sure I'm on a horizontal here. The center point for that wheel, or that point, it comes down inside of the wheel, so I'm going to cut that away. And that center point from here to here, if I dimension that, it needs to be 0.7. And see, that's the problem. See, it's inside of that fillet, so that's why we had to use the slice graphics. It's inside of that fillet where that point is. And then another thing you want to make sure, let's use the horizontal tool, make sure that point is horizontal with the center point. Okay, of course I did that twice, so it already exists. And then we'll dimension that peg that we're building out, which is where the link arm comes in. And the diameter of that is 1/4 inch. So now we finish the sketch, and we need to just select that little peg, and it gets extruded 3/8 of an inch. And let's keep going. Another sketch on there. And diameter of the next part is 1/8 of an inch, 0.125. Go ahead and finish the sketch. And we select that inner circle, and that gets built out another 1/8 of an inch. And then we'll go ahead and drill the hole on that little peg. So I just created the center point with the sketch real quickly. And the hole diameter is 1/16 of an inch, 0.0625, with a depth of 1/4 inch. Okay, so then the next thing to do, if we go around to the back side of the wheel, let's put a sketch on there. We want to create the spoke pattern. And you'll notice that the spoke pattern, we want to just build one spoke actually, but we need to be 15 degrees above horizontal, and then the spoke is 30 degrees. And the radius is 0.625 and 0.375 for the spoke pattern, 3/8 and 5/8 of an inch. So if we come back to this, now here's where you might use a construction line. So I'm going to go ahead and draw a construction line across. And then turn construction tool off. And let's just draw another line here. And notice, because I drew that construction line, I can see the angle that it's going at. I want to be, whoops, I do want to be 15 degrees above horizontal. then the next line, to be 30 degrees, needs to be a total of 45 degrees. Okay, so that gives me 15 degrees above horizontal and 45 above horizontal, which would make it 30 degrees between the two. And then if I do my center point arc, I can come in here and the radius, let's just draw it and then dimension it. I'm going to draw it bigger than it needs to be, because then we can always trim it. So the bigger one is 0.625. And the smaller one, 0.325. And now I can go back and trim off what I don't need. I guess you'll notice when I did that, I did lose some of my measurements. As long as you don't touch anything and move it, it'll be okay. But if you do want to add the angles back in, that's very easy to do. You can pick dimension, those two lines, and put the angle back in at 15 degrees. And those two lines at 30 degrees. I'm not sure why it's not fully constrained, but again, as long as you don't move anything, it should be fine. Go ahead and finish that sketch and do a cut extrude. Anytime you're going all the way through, you really should do all. Okay, and then finally we got one spoke built. Let's pattern that. So the pattern we're going to feature is feature 3. The rotation axis, we select a circle, we're going to pattern it 6 times, and we say OK. And one of the things to be careful of, if you built that correctly, of course, it's not going to run into your peg at all. If you did not constrain that well, it's going to interfere with your peg and not be symmetric around the peg. So we do want that peg to be symmetrical right on the wheel there. So there's the wheel.